The first lesson of our measurement unit is to be able to find the area and perimeter on the coordinate plane. We have this given triangle with its coordinates for each of the vertices, and we're going to find the area of the triangle. Area of a triangle is 1/2 base times height. I want to note that the height in any formula is the perpendicular distance, which means right angles, from the base to a vertex opposite of it. So we can calculate the base pretty straightforward. We can just count the boxes for segment DF. One thing I do want to point out is when we're trying to find the base and the height, they're going to create this 90-degree angle. So both those segments that create the 90-degree angle would be the measurements you use for the base and the height. So in our case, the base would be 1, 2, 3, 4, 5, 6 segments. And the height, we would count the vertical distance, 7. And we go ahead and multiply it. We get 1/2 of 42, which is 21. And then to find the perimeter, we would add all the sides together. So we already know the base is 6. And notice that these sides of the triangle are diagonal, so we can't just count the boxes. We actually have to calculate that. One way to do that is by using the distance formula. And the other way to do that is Pythagorean theorem. We can create these upside down right triangles along the diagonal segments. We can just count the boxes for that right triangle. So we'd have 3 boxes here, 2, 3, 4, 5, 6, 7 boxes here. And we can just plug that into Pythagorean theorem. But remember, to solve for c squared, we would take the square root of it. So it'd be the square root of a squared plus b squared. Again, this is the same thing as distance formula. It's just that instead of subtracting the coordinates, I'm just counting the distances between those coordinates. So we would have 3 squared plus 7 squared. So we would get 9 plus 49, which is square root of 58. Okay? So we have square root of 58 plus, and then we got to figure out the other one. So I can come over here and draw another right triangle using the other diagonal. So this is a side of 3. This is a side of 7. We plug it back in. And as you can see, it's the same work. It's going to be the square root of 58 again. And so now I have 6 plus square root of 58 plus square root of 58. I can go ahead and plug that in my calculator, and you would get 21.2. Okay. So now we're going to go ahead and look at our next example, and this is where you have to graph the coordinates for the quadrilateral. Go ahead and do that. So we graphed the quadrilateral, and now we have to classify it. We can't classify it until we know what the side lengths are. I'm actually going to skip part A and answer it at the end. First, we're going to go ahead and calculate the area of this figure, and the area would be base times height. So let's say I use base GD, and then I just have to have a perpendicular segment from somewhere on this base to the opposite vertex, or some sort of point on the base. So here would be my right triangle, and my base would be, or my height would be 1, 2, 3. So the area for a parallelogram would be base times height, and the height was 3, and the base is 5. So then the area would be 50. We're going to do something very similar, but this time we're going to calculate the perimeter. Well, we already know that this length is 5, and this length up here is 5. So the next thing we need to do is just find what these diagonal segments are. So if I create a right triangle here, this is 3, this is 2, 4, this is also a Pythagorean triple, if you remember what that is. Either way, I'm going to do distance formula. I'm going to use Pythagorean theorem version. I have 3 squared plus 4 squared, which is 9 plus 16, which is 25. So the square root of 25 is 5. And if I do the right triangle for the other side, same dimensions. 3, I have 4, we already did the work. So it'd be plus 2 more 5s. And essentially 5 times 4 is 20. Now I can go ahead and do my quadrilateral. I have 4 congruent sides, and it's a parallelogram because opposite sides are parallel. Then that means this has to be a rhombus. We don't have 90-degree angles, so it can't be a square. Last example we're going to take a look at is one very similar to the one that we just did. Just do one more. Go ahead and graph the quadrilateral. Same idea as in the last one. We need to know side lines to be able to classify this correctly. We can say that we only have one pair of parallel sides, but we don't know if AD and BC are equal to each other or not. So I can confidently say this is at least a trapezoid, but we need to know the sides of AD and BC to identify if it's an isosceles trapezoid or just a trapezoid. So now we're going to go ahead and find the area. The area of a trapezoid is 1/2 the height times the sum of the 2 bases. You don't have to know that formula for trapezoid. You can even calculate it by breaking down the figure into triangles or rectangles, and then you can solve each of these parts separately and then add the areas together at the end. So either method you choose, you'll get the same results. If we do this original formula, you'd have 1/2 times, well, I just have to count the height for one of these pink lines I drew in because it's at a right angle to the base. So it'd be 2, 4, and then the length of one base is 6, and then this one would be 11. So 6 plus 11. So I know 1/2 of 4 is 2 times 17 is 34. Okay? If you do the triangles and the whatever method, the other method, it'd be area of triangle 1 would be 1/2 base times height. We'll call this first one triangle 1. Let's go ahead and plug in the values that we know. 1/2, the base here is 2, and the height we already calculated is 4. So 1/2 of 2 is 1 times 4 is 4. Now we can calculate the rectangle in the middle. So then we would have area of the rectangle is equal to base times height. Our base for this would be 11 minus 2, which is 9, minus 3, which is 6. So 6, opposite sides are congruent, so it'd be 6 times the height, which is 4, and we would get 24. Now we just need to find the area of the second triangle, which is this one. 1/2, the base is 3, and the height is the same, which is 4. So 1/2 of 12 would get us 6. We add each of those together. So I know 4 plus 6 is 10, plus 24 is an area of 34. The last thing we need to calculate is the perimeter. So the perimeter would be adding all the sides together. So we have the 2 bases, which is 6 plus 11, and then we have to figure out what the lengths of AD and BC are. This is where you can go back and use the Pythagorean theorem or a distance formula. I'm going to go ahead and draw in the triangles and label the parts on the outside of the triangle. So I know the base for AD would be 2 and the height is 4. So then I can do, I'll do AD is equal to the square root of 2 squared plus 4 squared. And that would get us 4 plus 16, so it'd be the square root of 20. So I'm going to add the square root of 20, and now I got to figure out what the length of BC is equal to. And I know this base is 3, this base is 4, so it'd be 3 squared plus 4 squared, so 9 plus 16 is 25, and square root of 25 is 5. So this is not an isosceles triangle because square root of 20 is not equal to 5. So it's just trapezoid. And if I add up my perimeter, I'd have 11 plus 11 is 22 plus square root of 20 would get me to 26.5.